Our do now for this video is a bit of a challenging problem. We learned in the last video how to do completing the square with that plus box stuff, and I want you guys to try your best to do completing the square on this equation with an a, b, and c still in it. So pause the video and give this a little bit of thoughts and just see how far you can get with it here. This is actually a pretty famous problem that we're gonna talk about together, but don't be discouraged if you didn't get 100% of the right answer, but if you're at least on the right track, that's a pretty good sign. So I'm gonna go ahead and talk you through it now, but please, I do encourage you to see what you can do with this first. If you're gonna complete the square, the first thing you have to do is divide by whatever number is in front of that x squared. I find that kids forget that step a lot, but you can't do any plus box stuff until that a in the front of the x squared is out of there. So now my problem is going to say x squared. This part right here is going to be like b over a x. I just move the x to the ends. Plus c over a equals 0 divided by a is still a 0. So all I did for that blue step right there is I divided by a. Now for my next step, I need to do my box, but I need to get this guy out of here so I can put the thing I actually want in the box. So I will put down a plus box on both sides, and if I subtract this to the other side, it's going to say negative c over a plus box. Now this next step is a tiny bit challenging here, because what I need to do is take half of this guy. And remember what I told you guys earlier on in the last video? If you take half of a fraction, you multiply it by 1 over 2. That's going to make b over 2a, if you actually multiply it out. So my half that I write down right here is going to say b over 2a. Then what I need to do is I need to square this guy to figure out my box. And b over 2a times another b over 2a makes b squared over 2 times 2 is 4a squared. So my box is going to say b squared over 4a squared on both sides. So my left side is kind of crazy with these three pieces, but I don't really need to worry about it too much because of that nice shortcut I wrote down last video with the half. This parenthesis is just going to say x plus b over 2a with a squared. On the right side, I have to get a common denominator between these two things. So negative c over a and b squared over 4a squared. Well, in order to get a common denominator, I need a 4 for this guy. So I got to multiply by 4 right here. But if I did that, that would only be 4a, and that's a 4a squared. So I actually need to multiply by another a as well. So now if I were going to write this out, in order it'd go negative 4 times a times c like that. This bottom part right here is 4a squared, and then over here we have b squared over 4a squared. So what I'm going to end up doing with this right here, I have a common denominator on these two fractions. I'm just going to go ahead and then combine the tops, and I'm going to keep the bottom part the same. So it's going to look like this. For my next move, I'm trying to solve for x, so I need to take a square root to both sides right here. So the left side, not so bad. It's just going to say x plus b over 2a, like that. The right side is a bit gross looking. The top part, I cannot do like separate square roots to this and this because there's a plus sign right here. So this top guy here doesn't have anything nice that happens. What I'm going to do is I'm just going to rewrite it as a square root, but I'm going to go ahead and put this first part in the front and then put this guy afterwards. The bottom part on this fraction right here, the square root of a 4a squared does have a nice answer. The square root of 4a squared is just 2 and then a. So the bottom part is going to say 2a without a square root anymore. And I do need to put a plus or minus down on this answer right here because I did just finish taking the square root of both sides. So my last step, and hopefully some of you guys see where I'm going with this here, my last step is going to be to subtract that guy over. And when I do that, I'm going to have two separate fractions right here, but they both have the same bottom. So I'm going to combine it into one big fraction. So my problem, if I do this, will say x equals a negative b plus or minus the square roots of b squared minus 4ac all over 2a. So what we've basically done on this problem is we have just shown where the quadratic formula comes from. We started with just a random quadratic, ax squared plus bx plus c. And we did math that we already learned. And some of these steps in here, especially like this part, gives kids trouble. So don't be ashamed or like afraid if you weren't able to do that all the way by yourself. But you should hopefully at least sort of be able to follow my logic on this. Completing the square is what creates the quadratic formula. So we learned about the quadratic formula in Algebra 1. You have seen this formula before, and it's not that hard because we make kids do it in Algebra 1. But here's the thing. This formula is only possible because of completing the square. So completing the square is the real method right here, and the quadratic formula is just like a shortcut that we can use afterwards as a result. So if you go back and you're like, ooh, actually I want A to be a 7 and B to be a 4, well, cool, you plug 7 and 4 in the right spots over here. So that is where the quadratic formula actually comes from. Now let's practice how you use it. In order to use the quadratic formula, you have to make sure your problem is equal to 0. So make sure it equals 0. My first problem is already equal to 0, so it's just ready to go. We're going to throw this thing in the quadratic formula. It starts out x equals negative b. If my b is a negative 2, a negative b is going to turn it to a positive 2, plus or minus the square roots. And on the inside, I see kids make a lot of mistakes. So I have a way that I recommend you do these problems. I don't like to see kids put like a little negative 2 squared like this because then they mess it up later on. So what I do when I do these myself is I go ahead and I just square this number right away and put the answer. So a negative 2 squared is a positive 4. This first number under your square root should always be a positive because even if this is negative, a negative squared is a positive number. Then what I like to do is I like to take this whole part right here, negative 4 times a times c, and just multiply it all up. So if I do a negative 4 times a is 1 and c is 8, I'm going to end up getting a negative 32. If you treat this like a negative 4, and you get a negative answer, you're just going to put minus 32. You've already taken care of the negative in doing this. It was negative, so it's minus. If this would have been positive, I'd put a plus right here. So I have that going on for my top, and it is all over 2 times a. I'm just going to multiply that already. 2 times 1 is 2. So this is how I like to set up my quadratic formula problems. I find that I make less mistakes if I don't put all the little tiny parentheses. You don't have to do it that way, but it's a good idea. For the next step, I'm going to combine these guys into 1. So 4 minus 32 is actually a negative 28. So now my problem is going to say x equals 2 plus or minus, and the square root of negative 28. If this was Algebra 1, we'd be like, uh-oh, no solution. But now we know it's just imaginary. Now I will see kids who try to reduce the 28 with the 2 over here. That is a very bad thing because 28 is inside a square root, 2 is not. So you do not reduce these parts right here. You do a factor tree and you simplify this guy. If you do a tree on negative 28, you're going to end up getting 2i root 7. So this square root ends up being 2i root 7, and the problem is still over 2. So I did a tree on that part. The final step, just like with those dividing problems from the other lesson, we're going to split this up into 2 separate fractions. And then you don't have to show this step. You can go straight to reducing it if you want to. I'm just going to reduce though. You guys can see where it came from and I'll get my answer. So my answer is going to be x equals 1 plus or minus. Now I could not reduce earlier because this 28 was in a square root and this was out. But here, this 2 and this 2 are both outside of square roots, so you can reduce those. Those are going to make just 1 or I root 7. So you get your solution. The quadratic formula is another method that always works for quadratics. Every single quadratic can be solved with this method because it's just a manipulation of completing the square. Personally, the quadratic formula can be a lot of steps. So like if I can use another method, I usually like to, because you have to reduce and factor tree and all this stuff, but it's not that bad to set up once you know what's going on. So go ahead and try this next one for yourself, and I will talk you through it. Quad formula wants the problem to equal 0, so you need to make sure you've got that going for you. And then we're going to set up our formula, x equals negative b. That's going to be a negative 6 plus or minus the square root of b squared. 6 squared, I'm going to put down 36 right away. And then I am going to do negative 4 times a times c all at once. So a negative 4 times a 3, negative 12, times a negative 2 is actually going to be a positive 24. Negative 4 times 3 times negative 2. Since it's a positive 24, I will instead put plus 24. I already took care of the negative in that negative 4. Positive answer, plus. This is all going to be over 2 times a. A is a 3. 2 times 3 makes 6. So that is going to be my little setup right there. Next step is going to be to deal with the square roots. This guy right here is the square root of 60. So you would go and you would do a tree on 60. If you do your tree, again skipping the work to save time, you should get 2 root 15. So you would do a little factor tree on 60. Now I'm going to split off my problem into 2 fractions. My first fraction is just going to go negative 6 over 6. Plus or minus, again, I could not reduce the 60 with the 6, but I turned it into this factor tree. So it's just going to say 2 root 15 over 6. But I can reduce these outside parts right here. So my answer is going to be x equals a negative 1 plus or minus, and I can make this 1 over 3, keep the square root 15 the same. So 1 root 15 over 3 would be a good way of writing that one. All right, one more full problem here. This one has more going on with it, and there's a bunch of pieces here. So the first thing you should do is move everything to one side. When you're deciding where to move stuff, I super recommend you keep your x squared positive, like in this problem right here. So if I was doing this problem, which I'm going to, I would not advise a minus 4. I would instead push stuff to the right. That way I can have a positive for my x squared. You'll make little mistakes if you keep the x squared negative. So I always go out of my way to make the x squared be a positive. So that's going to be a 6x squared. Got to subtract x. So that's going to be negative 3x. And then I have to add my 8, which is negative 45. So there is my setup. Now, with completing the square, you had to divide by this number. You have to divide by this number, otherwise it's not going to work. The quad formula doesn't make you divide by the number, because you can have whatever you want for a when we developed the quadratic formula. But even though it's not mandatory, it is a good idea to divide out at least a GCF. I can look at these guys right here and notice that 3 goes into everything. If I divide everything by 3, I didn't do 6 because I didn't want to do a decimal here, but I could have done that too. But at least divide out a 3. What that does for you is it basically trims down your numbers so you don't have as gross of things going on here when you're doing your factor trees and stuff like that. So you've got this going on for your setup right here, and this is what we'll throw in the quad formula. So divide by GCF to make the problem easier. Not mandatory like with completing the square, but super helpful. So it's quad formula time. I'm going to do x equals negative b is going to make 1, positive 1, plus or minus b squared, negative 1 squared is still 1. And then I'm going to do negative 4 times 2 times negative 15, which is 120, positive 120, over 2 times a, which is 4. Square roots. Now I'm going to make my two fractions. X equals, it's going to go 1 over 4 plus or minus, and that's going to be square root 121, which actually is nice, just plain old clean 11. When I don't have to do a factor tree, it's just a perfect square. These are both nice answers, so I'm going to go ahead and get my two solutions. My first one is going to be 12 over 4, which is 3. That's if I add. And if I subtract, I'm going to get negative 10 over 4, which reduces to negative 5 over 2. As I've said in the other videos, anytime you get nice answers, it means this problem actually had magic numbers, and that would have been an easier way to solve it. But it's nothing wrong with doing it with the quad formula. It's just a little extra work. So, one more thing to do in this video. We are going to talk about the quadratic formula and about being able to predict what kind of answers our problem is going to have. What I mean by that is, how can I tell when I look at a problem if the answers will be imaginary or if they'll be real, if there'll be one answer, two answers, like what's going to happen with my problem? And if you think about it, what controls in the quadratic formula, what makes your answer imaginary? What has the power to decide if you're going to get imaginary answers? It ends up being this guy right here underneath the square roots. This part is what decides if your answers are imaginary or not. So b squared minus 4ac kind of controls if your answers are imaginary or not. So we actually give it a name. It is called the discriminant, which is kind of a weird word. And the discriminant is what guides whether your answers are positive or negative under the square root, which means real or imaginary for your solutions. So we're going to make a quick chart right here. If b squared minus 4ac is less than 0. So if it's less than 0, that's a fancy way of saying if it's negative. If this thing is negative, you will get two imaginary, so by imaginary I'm talking complex, solutions. Okay? If this thing is negative, square root of negative means you're going to have imaginary solutions. If, I'm going to leave a little middle space right here, if b squared minus 4ac is greater than 0, so if it's positive, you're going to have two real solutions. The only thing I've left out right here is what if it actually equals 0 under the square roots? So what happens if it actually equals 0? Well, if you have a 0 underneath your square roots, you're going to end up having negative b plus or minus the square root of 0 over 2a. Well, plus 0 minus 0 is the same thing. So what you'll get then is you'll have one real answer. It just repeats. So if you look at the discriminants, you'll be able to tell what kind of answers your problem ends up having. And we're just going to do one practice problem here because they're not bad questions at all. So they just say, oh, what kind of answers is this question going to have? They don't actually need us to solve it. They just want to know what kind of answers there will be. So I see that it's equal to 0. What I'm going to do is just set up the discriminants and look at that. Well, b squared is negative 3 squared, which is 9. And negative 4 times 7 times 1 is a negative 28. If I actually do that, I get a negative number. And if it's less than 0, it means my problem is going to have two imaginary solutions. So yeah, you can just look at the underneath part of the square root, and that'll tell you what kind of answers your problem should have.